Welcome to the third practicals of Introduction to Structured Programming, again with Julia, and I'm Michi. Yeah, and today we go deeper into programming, and we will go through the topics of the last lecture, and we will also have a lot of coding examples today. So let's look directly what is our plan for today.
Yes, exactly. So what are we going to do? Well, first we'll talk about this organizational methods we have this week, quite similar to last week, but a few new things. Then we'll look at uninitialized variables. This was also already a problem in the weekly exercises and mentioned in the lecture, but we'll look at it a bit more closely. Then I'll talk about the input buffer. You'll see what that means. Then a recap about structs from last lecture and binary representation, overflow, underflow.
And in particular, behind the input buffer and the binary representation, our two large examples are hidden that we will code today. But now the boring stuff, maybe. But it will get exciting at the very end. So homework 1 plus coding session 1, as you all know, and most of you have done it already, went to one of the coding sessions. And the next week there is the last opportunity to attend the coding session. Most of the time slots are already booked. Some are still available. So if you have not registered yet, please register now. And remember, there's also homework to be done and you need to submit it before your coding session.
Yes, so the weekly exercises, again, there are new exercises this week and they will be available around the same time than last week, so 18:15.
And these 10 exercises that we have here will be all the exercises of assignment 1. And as we said, you need to pass at least 50% of the exercises. You need to do 5 of these 10 exercises for assignment 1. Yes. Otherwise, you would get the point deduction.
And 5 of those then must be done correctly, so with all test cases passed in online GDP.
Yeah, exactly, yeah.
Just to mention that.
Yeah.
No. So the personal question hours, again, they're every Tuesday. Registration in Teach Center, and again you have to deregister if you cannot attend. So it's not a problem if you deregister on the same day, as long as it's 4 hours before your personal question hour, just so that the tutor doesn't wait for you and you won't show up.
Yeah. And use this opportunity if you have really more personal questions that you don't want to directly post on Discord, for example.
I think there's really a lot of time for everyone in the personal question hours.
Now the exciting part, Assignment 1. Today is the release. And there is an introduction kickoff video that Lena, one of our tutors, provided. Available starting from 6:15 in today's evening. It is uploaded to YouTube and it will be available at this time. There will be repositories on GitLab. So we talked about GitLab already, and for the homework 1, you needed to create a repository on your own. For assignment 1, this repository is provided from us, and it will be available probably by tomorrow if everything works fine. And then you can start programming and you can start working on the assignment 1.
Yeah, maybe just to mention this, there is also one repository which is public, which everyone can directly access after our kickoff video goes live. There you can already look at the assignment, you could already start coding, but you can't upload your changes to that repository because this repository is the one everyone you can see. Please wait for the repository that's really your repository that you will get later, and then push your changes to that repository.
Yeah.
And also always make sure well before the deadline that you can commit and push your changes to the repository.
Yeah. All the details about the assignment will be then also mentioned in this kickoff video. And yeah, just remember deadline is in 2 weeks. So we have 2 weeks. So yesterday in 2 weeks the deadline.
And always push your changes. But I think all of this will be mentioned in the video. Okay.
Now to the really exciting part. Our first topic for today. We want to talk about a bit uninitialized variables again. And I think we directly have a code example here. So we have this very short program here. We have the standard I/O included. We have a main function. We have a variable a, and we print the value of the variable a. And now the question, maybe to the chat, what is the output of this program? Because only 5 people are writing in the chat. We need more interaction. So, what is your guess? 66 should be random. More guesses, maybe arbitrary value. Void or none. Random probably 0. 0. Random value a 97. Okay.
I think most of you said something along those lines, so that it's just something random.
Yeah.
Or some value. But maybe we can try this out.
Yeah. So we just copied the code now
into online GDB. So
yeah, you know this already. And now we run it. Wow, value is 0. Someone wrote 0, or even a few of you wrote 0.
Okay, so everyone who wrote 0 is correct.
Yeah, run it again. Again 0. Again 0. Might get boring. 24,716. Nobody wrote this into the chat. Why? This is so obvious. No, it isn't, of course. So basically what most of you said is correct. A has some random value in it, and yeah, you don't have a guarantee that it has the value 0, even though it happened now multiple times, but you don't have the guarantee, as you can see in the online GDB output here. So you really need to be sure that you always initialize the variables. So if you set it now to wrong keyboard layout to 0, then you really have the guarantee that it will always be 0. But if you don't write some initialization value here, you can get everything.
Yeah, and maybe the mean thing is that most of the time you'll probably get 0, but sometimes you won't, as we just saw. So if you don't initialize your variables, it could be that 90% of the time your program works, but then 10% of the time it won't work.
Yeah.
Yeah.
We have a question.
Is it bad if we will be reassigned anyway later? This never hurts. It's basically no performance impact. And if you reassign to this variable later, I mean, you could avoid this if you're 100% sure that in every case you're going to assign a value to this variable before you're using it. But I think it's just, you should just always initialize with some value, just so you can accidentally happen. Maybe afterwards you change your program and then you introduce a case where you read from this variable without initializing it. This could happen easily.
For example, if you do something like this, now I write the scanf and I read the A, I will just write it informally here, blah, blah, blah. You continue with your program and you say, oh, I just want to read if in some condition I want to do the scanf, and in else I do something else. And if you go into this else, then your A is not initialized.
Yeah. And
if you write A equals 0 here, this is no problem because it's set to 0. No problem here. But if in this might happen, and it will actually happen.
Yeah. So if you write your assignment and it becomes more complex, it could happen pretty easily that you accidentally read from an uninitialized variable. Okay,
I think no more questions. So I think this slide is not so interesting because we already said it. Undefined behavior, anything can be stored in A, so always initialize it, and as we've shown it now, mistakes are not always that obvious that you have the variable and print it, because so to something different, now we have another program prepared. So with some concepts of the last lecture, what is the output of this program here? More interaction with the chat. I like this.
Does this also count for char variables? Yes, this counts for every variable you can imagine. Of course, you saw some more advanced ones, different stuff could happen. But if you create a variable like that without assigning a value, it doesn't matter which data type, it's always just then random data.
How you spoiled the whole example now.
Oh.
We also have the question whether it results in a compiler warning if you do not assign a variable. Yes, it should do. And global variables are assigned to 0 by default, right?
I think
is it true? However, you are not allowed to use global variables, so yeah, it does not apply for our course. Okay, yeah, and now I was not able to trick you. All of you said again it's random. Of course it's random because, as you spoiled it already, A is again uninitialized, so it can be anything. And if I add 10, if I iterate over the loop and add 10 in total to anything, then anything can be the output. And exactly this thing also appeared in one of the online GDP exercises. And some of you wondered why sometimes the test cases worked and sometimes they did not work. And this is exactly because A might be 0, but it can also be non-zero.
Yeah.
Okay. I think you got it. So let's move on to something more interesting. Maybe.
Yes. So right now I just want to start programming, and we'll get to everything what this input buffer is later. So what I want to do is I just want to read some character from the input, so from std in, so from the terminal. And I'll do this, okay, I'll create this character C, then I'll print some prompt, something like this, something short, and then I will do the scanf, and now with this person C, like in the printf, I can read a character. Okay, like this. And now I want to print it out again. Maybe character, and then I'll just print it. Maybe a new line at the end. Oops.
I think you've the wrong people out now.
No, it works.
It's the right one. Okay. So we print this character C now. So basically it's something that you have already seen in the weekly exercises, just the input of a character. And you did not initialize the C. We have learned something.
So I didn't initialize the C because I'm 100% sure I'm going to overwrite it here. But maybe just so, because to do everything we just said earlier, maybe I should initialize it. So that's definitely not a problem. I initialized it. I'm anyway going to overwrite it here and then print the character. Let's try it. I'll use the main.c and output it to, I don't know, let's call it just the same as the C file, execute it. We can enter character, maybe A. Now we also need to press enter. And okay, it works.
Yeah, so this is very nice. Okay.
Okay, but maybe I want to read multiple characters. So I want to read as many characters as I want, and then once I enter a queue for quit, I want the program to exit. So we'll use one of those loops you saw in the last lecture. And because I want this character input to happen at least once, I'll use a do-while loop. So you could, of course, use every type of loop, but I'll use the do-while loop because it fits my use case.
So now the difference between the do-while loop and the while loop is that the do-while loop is executed at least once.
Yes, because in the condition, when I want the program to stop, is when the character is equal to Q, or worded differently, I want to repeat this loop until the character, as long as the character we entered is not Q. And if we just wrote a while loop instead of a do-while loop, then yeah, I would compare this character already up here, and then I have to initialize it here somehow that's not Q. And it would also work, but I think it's nicer for this one.
Can I remember you at the style guide that we put the brackets always in new lines? Except for the while after the do while. This is okay.
Okay, then let's compile it and let's test it. Maybe an A.
What happened now?
Okay, now something is weird. We have enter character A. Okay, this works. But now we get this enter character and then character colon and then nothing.
Have you pressed something in between or
no? I mean, I can try it again. The same thing happens. So we have apparently nothing. So this is.
So this enter character is then empty. The character printed is printed again. So this loop is executed twice. 2 times. Yeah.
Because we get enter char twice, but they only enter one. Yeah, the queue works, but maybe to find out why this happens, maybe we can figure out what this invisible character is, because it prints a character here. We have character colon, so maybe try with D and then look at the ASCII representation.
I have to admit, we have really some expert already in the chat that already know what we are doing. Yeah, but okay. Continue. Yeah.
Okay, so A works. 97. We know that's the ASCII representation of A, and then okay, here's nothing, and then character 10. So apparently we read a character with the value 10 directly after our A, which is the 97 here.
What is the character 10?
And apparently it doesn't matter what I type, it's always the character 10. Do we have some ASCII installed here where I can look this up? No.
But we can. Should we use the debugger?
We could use the debugger.
Yeah. So we need to.
I'll set a breakpoint maybe here before we print the character.
Yeah.
And then we'll create this.
Yeah, this is fine.
Then here the executable file, we called it main. We don't need this. We then, very important, we need to compile the program again with -G to enable our debug symbols the debugger needs. So it knows stuff like line numbers. Okay, so let's try and debug it. Okay. It could be that the debugger is not working.
It looks like it's not working.
Yeah. Okay, we can't use the debugger.
Okay, now this is unfortunate because we're not using the virtual machine now.
Yeah.
We work directly on Windows, and yeah, Windows makes problems.
Okay, so we could just tell you that we would have figured out with the debugger that the 10 here is the ASCII code for the new line.
So the \n.
So yeah, so this one, so the character you get when you press enter or return on your keyboard. So apparently we're reading an A and then a \n in 2 loop iterations. And I mean, I'm also typing that because I'm pressing A and then I'm pressing return. So but why is it 2 loop iterations?
Yeah, because we always read one character.
Yeah, okay. Then maybe we could try something else and try multiple characters. Maybe, I don't know, let's try just hello, because I can enter more than one. Press return and oh. We get multiple characters, and if I change this peg, okay, we can see that first the H is read, then in the next loop iteration the E is read, in the next loop iteration the L, and another L, then the O, and then here you can also see that this is the return. So here we have an extra new line, and then we are back. So why does this happen? And this is something because of the input buffer.
You want to draw something. Oh, we need to change here.
This one.
This one here.
This works?
Yeah, we see something here. Maybe a bit smaller. So this is the input now.
Yes.
Perfect.
So this is because when we type something in scanf, it goes in the input buffer. And the input buffer is just something that we have in our memory. So I represented this here. We type this hello, and then we type the new line at the end. Okay, if we read one character here with this scanf now, but we enter multiple characters in the input buffer, what happens then is scanf reads the first H, and basically the H is then cleared from the input buffer. And this is what happens in the first loop iteration, where we get this H here. Then in the next loop iteration, the input buffer is not empty, and therefore it doesn't even ask us if we want to input some more input. It just reads the next character, and then this one is cleared from the input buffer. And this continues up until the \n, which we can see here. Afterwards, the input buffer is empty, and when we call scanf, it will ask us again to provide new input, to type something again.
So this scanf would now go one step to the right in your drawing?
Yes, and we can check this again. I type hello and the \n. It read the H, the E, the L, the L, the O, then the \n, and then the input buffer is empty, so it asks us again to input something.
And now you would enter like Q and \n, and this would be then again represented in the input buffer.
So then here we would get the Q and the \n. And what happens here is why we don't get the \n is because we never read it, because we get this Q, it's removed from the input buffer, and our whole program stops, and we never continue reading.
So now this is nice that we know the reason why it doesn't work. It would be nice that we can also find a solution for that.
Okay, so let's go back to our code, and maybe one idea you can come up with is, because we always, when we want to read a single character with scanf, we always have to type 2 characters. This is because the input, as we have seen here, is only finished once I press return. So even if I just type 1 character, I always have to press return. So we always have 2 characters in the input buffer. This means that after we read 1 character with scanf, we always need to at least read the \n, so that we don't get it in the next loop iteration. And just so that we are clear from the beginning, what I want to happen now is that if I type multiple characters, I just want the first one to count and the rest to be ignored. So after we read one character, I want to ignore all characters up until the \n, and then I want to restart my loop iteration. Are there any questions?
So far, just about online GDB.
And how could we do this? Well, we could do another loop in here where we read a character until we encounter a \n, and then we stop. So let's try this again with a do while. Okay, I didn't know this would work. Okay, so scanf. We want to read one character.
Maybe you can scroll up in the code a bit that we can read everything.
Want to read one character. Well, we need a variable. Maybe is new line, and then it doesn't matter to what we initialize it. So because we overwrite at least once, but maybe let's just initialize it with 1.
Doesn't matter.
Something that's not new line. I mean, even new line would work, but because you overwrite it. So we read one character, and we do this. We do nothing with this character except checking if it's not the new line character. So what we're doing here is we're reading one character, check if it's the new line. If it's a new line, we know the input buffer is empty because that's what the user entered. And then we start with this whole loop again. But if this is not the new line, the user inputted multiple characters, and we want to clear all of those until we reach the new line and then start again. So maybe let's try this.
Yeah, maybe some semicolons. One more in 12.
Why did I write that? Okay, maybe let's first try the A. Okay, this seems to work. We are not getting it twice. It's only once now, and maybe hello now. Okay. Now we also just get the first character, and then we get prompted again. Should I draw it again, or?
I think that I think it's clear. Yeah. Maybe this is now like we need to declare a new variable here. We need to do the second do while loop with the scanf inside. Maybe there's a more compact way how you can write this.
Yeah, and we can write this more compact. Especially, why do we need so many lines? Well, we first need a variable where scanf then writes one character to, and then we need to compare it. But there's also a function called getChar, which reads one character from the input buffer and stores it and just returns it. So we can store it into a variable.
So this is basically similar to scanf, %c.
Yes. So this would work like this now. So if you didn't get all of that with what this does, what is a function, etc. So we can use getChar like this, where we just write getChar instead of a character. And we still need this char is new line here. Sorry. I was already a step ahead. But now we can see, okay, we have this char is new line here. We assign something to it and then use it down here. But then never use it again. So one thing we could do is, instead of declaring a variable, assigning one value to it and then reading again from it, we can just use getChar in here.
So we skip the variable.
Yeah. And now, because we just had this variable which we created, wrote one value, and then read this value again. So instead of writing and reading that value, we can just use it directly here. And now the do while loop is also a bit useless. And instead we could just write it like this. I'll do it like this now. So, and this will clear our input buffer.
Oh, this is now very compact. It's just a one-liner.
We can try it again.
So just the H remains, just the T remains, and the Q works as well again. So this is what we wanted to achieve, right?
Yes. So now we can read one character, really just one character from the user, and not get this weird behavior where the next character we read is something we don't want. Were there any questions?
Yeah, there is like one more comment. Someone did it with scanf and used the space before the person C character. This is of course also an option. We think that this option that we presented is a bit like a more cleaner option, and it's better readable because you can really look at the code and know what is meant with that. Of course, what you have done is not wrong, but it's maybe not immediately clear why this is working the same way.
Of course, you could also replace this scanf here with the getChar, like this.
Yeah, so you can use scanf or getChar like interchangeable in the case of characters.
Okay.
There's no... And just getChar, yeah, but this is what you have shown. Like, yeah, and our solution is better if we have some larger input. I think this wouldn't work with the previous scanf. And the style guide, we also had a question about this. You can find it on the Notion page, on the page assessment of assignments, and then in some subcategory there. And this is only relevant for the assignments and not for online GDB.
Yeah. So, just have the example also on the slides where we can look it up afterwards.
So, structs.
Let's continue with structs. As a quick recap, do you want to do it?
Yeah, I will do the recap. So we've seen this in the last lecture, and we said we have multiple variables and that we want to group into one new data type, into one new variable. Yeah. I don't know what was the example in the lecture last time, but maybe we have a person, and the person has a name. They have maybe an age, maybe a weight, a height, and so on. So we have multiple values that all belong to this person, and it would be nice that we do not have 4 variables for this person, but we just have a single variable that stores all these properties.
Yeah, right. The lecture used the example of coordinates.
Of course.
Latitude and longitude then.
Yeah. I always always watch the lectures.
So I will do just a quick example with structs and also show you one new thing you can use when using structs, which is, I think, something nice. Can't I scroll up here? I don't know.
No, you can. You should.
No, okay, now it works.
Okay.
No, VS Code did something weird. Okay. And what I want to do today is create a struct for a point. So quite similar to the coordinate example, but I just want this to be a quick example. And some recap about how the syntax is. So how do we create this struct, this grouping of multiple data types? Well, we write struct, then our name, which is point, then do the curly braces, and now we can type the member variables of the struct, which are basically what other data types this one consists of. So we have an integer x and an integer y. So why do I do these underscores here? That's just because that's how you're supposed to name them according to our style guide, and you should also do this in your assignment, that you always name them like that.
If we are very precise, then we would also have to name our struct with underscores here.
Yes, but that's a reason we'll come to later, so I won't do this.
Okay.
Okay, and to use it in the main, when we want to use this new data type point, we always need to type struct point. So this here is basically like when we write integer. So this is our data type, the struct point, and then point.
So the last is the variable name. Okay, and now it's again uninitialized, so we should immediately change this, that it's uninitialized.
So how do we access this? Well, we can access the x, and we can access the y, and set these two variables in the struct to some values. And we can also print this. So the x coordinate and the y coordinate.
Oh, without the 0.
Sorry. Okay, we can try it. Compile, execute, and with a \n, we see, okay, we have this point with the value 3 in value x and 4 in value y.
Okay, yeah, this works very nicely.
Okay. But now, well, I just want to create a variable and I want to assign the value 3 and the value 4 to it. And I think this is quite long. I mean, these are 3 lines I need to type just to initialize this variable. With an integer, I could just do this.
Yeah, I mean, if your struct would consist not of x and y, but it would consist of 20 such attributes,
yeah,
then you would have to assign 20 things to it.
Yeah, I think this could be done shorter, and there is a way to do this shorter, namely initializer lists. Initializer lists allow you to initialize those members of the struct, so of those 2 integers in our point struct directly when we create it. And in those initializer lists, we initialize the struct members in the same order they are declared in the struct, except when we are using designated initializers, and I'll show what this means now. So don't worry if you didn't get that. So how does this work? Well, instead of writing this, we can just use this. So we want the x to be 3 and the y to be 4. And this is the same as here. So x is the first one assigned 3 and y is the second one assigned 4. You can try this. Yeah, and this works. But now maybe if I have a struct with many different members, it could be that it's quite difficult to remember how their ordering is in the struct and then have the same here.
Yeah,
so there is something we can do differently. Yeah, or maybe I'll just do it here. When we are creating this initializer list, we can specify which variable we want to initialize. So for example, if we want to initialize the y first, we can write just like when we access it, dot y underscore equals 4, and then the comma like before, and then dot x equals 3. And this should be the same as before, just that we now switched how we arrange them. And you can see the same output again.
Yeah, I think this is even more readable now because you don't need to remember in which order are the attributes of the point, because you can just see it in initialization list here.
Yeah. So now I want to motivate the next thing. If we have 2 point variables, it could also be quite weird that you also have to type the struct point all the time, because we know point is a data type. Why do we need to write struct point? And there's also a solution for that, which I think you already saw in the lecture, which is the type def, where we can create an alias for a data type, and now we can create an alias where we can provide a name for struct point. So instead of writing struct point, for example, we could only write point. Okay, how does this look like? Well, if we name this differently, maybe like this, and then down here we can do typedef struct point. So here we write how we want to name it, and here what this new alias should be. And now we can avoid writing struct all the time because we have this typedef here. Yeah. I use point down here.
Okay, yeah, so this is...
Okay, this works, same output. And we don't need to write struct all the time. And this can also be done a bit shorter. Instead of doing this in an extra line, we could just write typedef in front of the struct here. And then at the very end, write how we want to name this. Also works. So now we have the point, and if we do it like this, because this name here, we don't use it anywhere, we can even omit it.
Okay,
yeah,
that's it. Yeah, I have a really interesting question in the chat. This was regarding this initialization list here. And the question is, you don't write anything inside the struct, probably this is meant here then. Isn't that less readable but more concise? So what I want to say here, we have to distinguish two things here. We have to distinguish the initialization list and the definition, the declaration of the struct, basically. This thing here is not a variable. It is just declares
data type.
Just declares the data type. It just says we have a variable x and we have a variable y inside of the point. With this has no memory, no value is stored in it. This is nothing. Yeah, we cannot use it directly. Same as you would say we have the data type integer, but then it also does not have a value.
Yeah, so the data type integer, that's just something what we use to describe something and not like an actual value. So the data type integer is not the value 3, for example.
Yeah. And now we do here, we create a variable of this type. So this is the building plan, more or less, for this variable. So we know that this point variable has this x and the y. And then we always need this here, because otherwise the point doesn't know of which data type it is. And now we want to make it precise which of the members, so these are the members or the attributes of the struct, should be initialized with which value. And if we write this, the designated initialization list here, so we will specify which attribute should be initialized with which value. And this makes it better readable, because if you omit this here, you need to remember in which order you have written this, the building plan for the struct at some point. And here you can forget about the ordering. Hope this makes it clear. And another question is, can you write a function inside a struct? And this is a no. You cannot write a function inside of a struct.
There is a way, but way too advanced.
Yeah, but that you actually write it in the struct is not possible. Okay. Is there ever a reason to not use a typedef?
There could be some reasons, but for us, no.
No, yeah.
No.
See, is the best way for readability and clearly yet, or is the basic struct better? I'm not quite sure what the basic struct is. If you mean now the typedef and not typedef struct, then use the typedef struct. Yeah.
And maybe also note that I write the type point with a big P and the variable point with a small p, so you can distinguish those.
I think it's
and
clear.
yes, you can of course pass a struct to a function.
Yeah, you will see this today in today's lecture, I think. Okay.
Yes, so I think we can continue, right?
Do we need some light? But I think it's bright enough here on the camera, or should I switch it on?
I think it's fine.
Okay, it's fine. Yeah, your example.
This example is of course on the slides, so you can check it out later again.
Okay, now we go to the binary representation again. Last time we went through the binary representation very fast and just repeated or recap what you have probably seen in some other subject already. And today we want to code something with the binary representation. Yeah, and I think I have it on the next slide. We have given some integer, or in this case we use a character. So we have a character, and now we want to print its binary representation. Yeah, it's as easy as that. This is our task. What concepts do we need for that? We need the bitwise operators, and you have seen them in 1 week ago in the lecture, I think. No, 2 weeks ago in the lecture, very briefly on one slide, and probably the lecturers told you will never use them. Now we use them today, that you've seen them at least once. And of course, as the binary representation consists of several zeros and ones, we need to loop over something that we can print this, and we have to distinguish 0 and 1, so we need conditions. So greetings to the lecturers. We need conditions to distinguish when a 0 or a 1 is printed. Okay, what do we need to do? I think this is now the drawing slide. This one is the right one. Okay.
Should I hide the...
Yeah, maybe hide we don't need the slide. This was the wrong. This is the right.
This is the one. Okay.
Now I have enough space here. Okay, now I just pick some, I will say I pick an unsigned character. It basically doesn't matter, but I just picked an unsigned character in our case, call it number, and it has the value 42. And I also have the binary representation here. So for 42, the binary representation is these 8 bits here. So it's 0, 0, 1, 0, 1, 0, 1, 0. And just have the space here because I want to be more readable, but it doesn't matter too much. And now our goal is that we can print these bits from left to right of our character. Yeah, how can we achieve this? I will, in the example, create a second unsigned character, which I call bit mask, and I set it to 1. So just accept it now, this name, and it just has the value 1. So if we think about the binary representation of 1, then of course all the bits are set to 0, except for the very last bit. Yeah? So this is the number 1, and this is the number 42. And now I want to do the following. I would just write my number 42 again, maybe this way. And I'm now interested in the very first bit, which is now marked in red. So I want to be able to print this bit. How can I do this? I could take the binary representation of this 1, take this bit here, which is set to 1, and shift it to the left for 1, 2, 3, 4, 5, 6, 7 positions. Yeah, so I would write here, I take my 1, and then we have an operator in C for this. This is the smaller operator, and in the direction left, see it as an arrow to the left side. And by 7 positions. Yeah, and if we do this, then this 1 goes to the first place. So we have here the 1, and everything else will be filled up with zeros again. So we have now aligned our, I called it bit mask here. We have aligned our bit mask and the present bit of this bit mask with the number 42. And now what can we do here? We can apply a bitwise AND operation. So I will do now the bitwise AND. The bitwise AND is true if both bits are set to 1. In all other cases, the AND is 0. So in particular, for all these positions here, we know that the 1, this bit mask, is 0. So we can immediately conclude that all of these bits must be 0. And now, at the very first position, the bit mask is now 1. The 42 is 0. So in our case, the bitwise AND would be 0 again. So, and now this is, I get this number here. Everything is set to 0. So we know that its value equals 0. Okay, and now this is the first case for the bit, for the very first bit. And now I will do a different example, and then you might see what I want to do. We can have the 42, 0, and now maybe go back a bit. I take this bit now, yeah, which is again marked in red. Now I want to shift this number 3 times to the right, because then I get to this position. So I take it 3 to the left, I'm sorry, 3 to the left. So we get 0, 0, 0, 0, 0, 0, 0, and we get here a 1. And now again I apply the bitwise AND operation. Again, I know all of these bits are set to 0. So here I immediately get 0 in the bitwise AND. And now I'm just left with this position. And now we see that the 42 has the bit 1 set here. Our bit mask has it set here. So this will become a 1 in the bitwise AND operation. Should mark it in red. And now what can we conclude? Not all bits are set to 0. And by this number is definitely unequal to 0. So to generalize this now, if we do this shift with the bit mask, apply the bitwise AND, and we get a 0 value, we know that the bit in the original number is 0. And if we do this and get a 1 in the, if we get a non-zero number in the output, then we know some position must be 1 and it must be exactly this position here. And this is a very simple algorithm. Maybe it sounds very difficult now, but this is a very simple algorithm actually to print the binary representation of a number. And this is what we want to implement now. Questions?
No.
Okay, yeah, then they will appear when I am programming. Yeah, okay. So this is what we want to do, and yeah, we need to switch back here to the coding part, and we go here to our main function. So let's put it away, and now we do what we wanted to do. We say we take this unsigned character number, and we will do it. With 42, and we take this unsigned character bit mask and set it to the number 1. So this is exactly what we were using. And now maybe we can we split it now? Can we do the splitting thing?
Mm-hmm.
Okay, now we see everything, yeah? So now we said, okay, we need to shift it 7 positions to the left. to get the first number. We need then to shift it 6 positions to the left for the next number, then 5 positions to the left for the next, and so on. And if we go here, if we do it for the very last bit, we do not need to shift it at all because we are already on the right position. So we have a shift of 0 positions. And this can be represented, of course, with a for loop. So call it maybe this variable that we're using in the for loop, the shift length. And we said at the very beginning, it must be 7. Then, how long should we do it? We should do it until we reach 0. So we have to be sure that the shift length is always at least 0 when we want to do this.
And if we shift the number by 0, then it's just the same number, of course.
Yeah, exactly.
Yeah.
The shift by 0 is unchanged. And then in each iteration, the shift length should decrease by 1. So we could write here shift length minus equals 1, or just write minus minus here. Okay, so this is now the for loop that we need.
And yes, in the chat, that's correct. We check basically every position in this number, so every bit in this number with this bit mask if it's 0 or 1, and then we print it accordingly.
Yeah, exactly, yeah. Okay, now we move back. Okay, so we need to do the shifting here. So maybe we take, maybe I could also take an unsigned character here, but it doesn't matter. So we take now unsigned character and I call it number shifted. No, I can't, bit mask shifted. Bit mask shifted. And I take my bit mask and apply this smaller operator, which shifts this bit representation by shift length bits to the left. Yeah? So with this, in the bit mask shifted, we exactly get this value, for example, where the 1 is on the very left side. We should maybe make it a bit smaller. Can't make it small enough that you can read it. I'm sorry, but you know, we get these values here. Yeah. And then from the result, maybe just call it again result, unsigned character result. We said we take our number and apply the bitwise AND operator between the bit mask shifted and the number. And then we said, okay, depending on if the bit is set or not, we get now a value which is equal to 0 or which is not 0. Yeah? So we make now a case distinction. If the result is unequal to 0, in this case, we just print a 1. Yeah? Remember, in this case, where the result was unequal to 0 here, we had some number written here, some bit is set, and this is exactly the bit of the number that we were considering at this moment. And in the other case, so in the else case, we just print 0. Okay, and maybe after the main function we write this return, and I hope that we manage to see all the code again. So this is the relevant part here. So we have this number, we do this, we iterate over it, do this shift to the left, then we do the bitwise AND and then print it.
Yeah, maybe just so to mention this again, I mean it was implicitly mentioned by you, here we iterate from 7 to 0. This is because we go, of course, from left to right when you're reading a number. We print the most significant bit, or the most significant digit of this binary number first, and then we go to the less significant ones.
Mm-hmm.
So just to explicitly mention this.
Yeah, exactly. Yeah. Thank you. Okay, and now the interesting thing is, does it work? Yeah, we can do this. We have the command already somewhere here. Okay, compilation work, and if we run it now, we get. Okay, let me run it again. Yeah, you can see this. We get really the correct output. Maybe I can print \n at the very end to make it a bit better. Yeah. Okay, so we have this as the result. And if I look up now my nodes, 0, 0, 1, 0, 1, 0, 1, 0, this is exactly the same number that I was talking about before. So this is the binary representation of this number 42. Yeah, very fine. So we have one question. What's this bit mask shifted by the shift length? Yeah, maybe we have the drawing again.
Yeah, here. And then do it full screen again.
Thanks a lot. So this is this bit mask where the very last bit is set to 1. And if we put here now some number, and by this number we shift the 1 to the left side.
So this 1 is the bit mask.
The 1 is the bit mask, and the 7 is this shift length.
Because this shift length at the start is exactly 7. Oh, you can see it. Never mind.
Yeah, but yeah, the shift length was 7 at the very start. So we take this representation and shift every bit 7 times to the left side. So we could, for example, say this 0 goes to the left once, and then a second time, but then it disappears because there is no more space. And in particular, the 1, if we shift it 1, 2, 3, 4, 5, 6, 7 times to the left side, we get a 1 here, and everything else will fill up with zeros, because on the right side of the 1, we do not have anything here, so it will just be filled up with zeros.
Another interesting question. So the binary from form of 42 has already existed, and now you're coding to represent it, right? Yes, this is what we're doing. Of course, these binary 1s and 0s is the thing stored in our computer's memory when we write 42, but we want to see exactly what's in the memory, and we print this here. And what is written here is stored in the memory.
Yeah, so this already pre-existed, but now we make it visible to you. What does the unsigned mean? I think this was last lecture with signed and unsigned number types, where unsigned just means that this type can't represent negative numbers, only positive ones. Yeah. Okay. Now back to the slides. We have seen this, and now I have a very nice quiz. And David, now this is the moment where you should listen. I already spoiled it to you a bit. I've read this on ORF at some point. Sorry, it's in German. I will also read it in German. Ein US-Teenager hat am Wochenende im Videospiel Tetris einen außergewöhnlichen Rekord aufgestellt. Der 16-Jährige hat als erster Level 255 geschlagen und damit das Spiel zur Wiedergeburt gezwungen. Das bedeutet, dass das Spiel auf Level 0 zurückspringt und damit praktisch von vorne beginnt. So this Tetris player managed to reach level 255, and afterwards the game started back at level 0. And now the question why? And now, we have one answer already. Overflow.
Yes.
Yeah? And we can try this now out. If we go here to our example, and they said in this article, the player reached level 255. 255. We compile it. We run it. 255 has the binary representation, everything is 1. All the bits are set to 1.
Yeah. So if you now think about it, what if you want to add 1 to this binary number? Well, we would need one more bit here to set to 1, and then all of these would be 0.
Yeah.
Yeah. But
yeah, we try it out now. We take the number 255 and number plus equals 1. Yeah? What happens now? Clang and main, and now everything is back to 0. So this is the same behavior now. We have reached again level 0 because this 1, which would appear now, would be left of all the zeros, but we do not have the memory available to store this additional 1. We only have these 8 bits, so we just have these 8 zeros and we're back at level 1.
Yeah, and if you want to see more clearly why this happens, if this is not clear to you right now, I think in the last practicals we did some example of how counting in binary works, very briefly. Maybe try just writing down 4 bits and then count to 1, 1, 1, 1, and then try adding 1 again, and you will see that all of these ones will become 0 and you need one more digit to represent the next higher number.
Mm-hmm.
But we don't have this digit in a character because we only have 8 bits, and it just gets lost, and now we have zeros.
And we have the same behavior, of course, if we initialize this character to 0. I mean, this is now very obvious. I probably don't need to show it to you. If we have the character set to 0, then the binary representation is all 0. And now, if we subtract from this number 1, then from 0, it's unsigned, so it can only represent non-negative values, so just 0 and all positive values in its range. So this would be a negative 1, which cannot be represented. And in this case, we have the underflow, and we go back to this representation where everything is 1. Yeah?
Which in the case of an unsigned char is 255 again.
Yeah, so this is the value where we started from.
Mm-hmm.
Yeah, and so -1 is impossible for an unsigned integer. And for that reason, if we would print now the number here, we can also do this. I think I need to use %u because it's unsigned. Because we have an unsigned character, unsigned number, we need to use %u in this case. We get again, that's 255, so it's the largest value that can be represented.
Yes.
Okay. We have one more question. So is the shift length always supposed to be 7?
So I guess because it's not always 7, we decrement it. So by 1 every iteration. So it's 7, 6, 5, 4, 3, 2, 1, 0. And yes, if we want to print all of this for 1 byte, we need to start at 7 and end with 0. So we have in total 8 loop iterations, and the byte has 8 bits. If you want to do a longer binary number, more than 1 byte, then you would need to start at a higher number.
If you want to print an integer, you would need to use 4 times 8, so it's 32 the length. 0 is included, so we need to start at 31 in this case.
Yeah.
Okay, back to the slides. I think on the remaining slides, it's just what we have already seen, the integer overflow and the underflow. It doesn't matter, we have seen this already, just as a summary that you can look it up later in the notes. So altogether, we've seen the uninitialized variables at the very beginning, then you continued with
the input buffer, and then I also showed you how you could use structs in your program.
Yeah, and then we did the binary representation. Okay. Do you have any further questions?
So I think we'll just do some questions in the chat now.
Yeah.
So if there are any remaining questions, I think we did really well this practicals stream. I think we nearly answered every question in the chat, but maybe there are some left or we missed someone.
Or maybe some more question arise in the very few minutes.
I don't understand this question.
Yeah, so it's not so important. And last time when we answered a lot of questions at the very end, and the lecturers were tiny little bit mad at us that we did 5 minutes more. So it's also okay if we can stop on time.
Yeah. So today at exactly 16:30, the stream will be gone.
Yeah. Okay, I think no more questions here now, so I think we can conclude for today.
Yeah.
Okay. Back to this view. So now we're 2 minutes even earlier, so maybe this compensates when we do a bit longer.
Okay, and I understand this question now. I think.
Oh, now there's 3 questions.
He
okay,
meant,
we'll answer them.
how can I crash my PC when coding online GDB? And is it possible with memory overflow or something? No, that's not possible. When you run your program on your system, if you don't start deleting files with your programs or anything, you can't do anything wrong with underflows or overflows or some other stuff where there are some consequences for your computer. So you should be safe. I mean, you can, of course, always in your program start deleting files, but as long as you don't do this just with the things we show you, you should be fine. Can I do the weekly exercises if I'm not yet enrolled? Yes, you can actually do this.
Yeah.
If you go to our website, we showed, so coding.tugas.at/home, you will always see your username.
No, sorry.
Oh, if you're not enrolled, you don't have.
I know you. I talked with David about you before the lecture. I will send you, I don't know your email. Please send David an email that you want to have access to online GDB, and we can provide you with the correct username.
Yeah. Sorry, I thought you meant register to the course.
Yeah, no.
You can do this exercise if you're not registered to the course, but if you don't even enroll to the study program yet, then no, you can't do it.
Write him an email with your matriculation number, please. So your matriculation number is crucial. I hope you have it already. Okay.
Okay, I don't know much about the mentoring program because that's something different.
Yeah. So,
but yeah. I don't know. And I think
that's it now. Now it's exactly half. Yeah.
So 31.
Okay. Then thanks you for listening. Thank you for watching the stream. Now we continue then with the lecture with more on functions. Next time there will be also the practicals about functions, and the last time as a stream. And in 2 weeks we will meet each other then in person in the lecture hall. Yeah. And we're looking forward to this. Yeah.
And we finally have the lecture hall.
Yeah. But next week we will see each other the last time on the stream. Then have fun with the lecture and have fun with assignment 1.
Yeah.
Okay. Bye.
Bye.